Hi all. In this talk, I shall give the meaning of number line and try to give its significance. I shall do this as 5 questions. Question 1. What is number line? Look at the screen. If we take any straight line and fix any two distinct points of our choice on it as 0 and 1, then that straight line is called number line. In short, a number line is a straight line with 0 and 1 marked on it. Question 2. What is the immediate consequence of marking 0 and 1 on number line? By fixing 0 and 1 on a straight line, all the natural numbers as well as integers are automatically fixed on it. All the rational numbers are also fixed on this number line. We can actually plot all these rational numbers on the number line using the two Euclidean instruments, which are compass and unmarked roller. Question 3. Does rational numbers exhaust the number line? This word exhaust is very important in throughout the mathematics. Another way of asking this same question is this. If number line is white in color and all rational numbers are marked green, does the white line becomes completely green? Or are there white portions still left out after marking all the rational numbers? There is a third way of asking the same question. Look at the screen. Two line segments of any length are given. Can the larger of them, say AB, can be expressed as a rational number times of the shorter, say CD. In other words, are there positive integers m and n so that length of AB is m by n times the length of CD? If we let the length of CD as 1, so called unit length, then the length of AB will be m by n. So, a fourth way of asking this question is if length of every line segment is a rational number. In other words, are rational numbers sufficient to represent or measure every length that ever exists? Now I will answer this third question. It was believed for hundreds of years that every length in nature can be represented by a rational number. A student of Pythagoras has brilliantly shown in a half-page proof that there is a length which cannot be represented by any rational number, and he called it an irrational length. Of course, there is a story where he was murdered for this discovery, revolutionary discovery. Imagine mathematics without irrational numbers. It is like physics without quantum physics. Now, simple logic will help us to realize that there is not only one white point on the number line but infinite of them, corresponding to irrational lengths, that is irrational numbers. Question 4. Why is number line called real line? Rational numbers and irrational numbers together are given a common name called real number. Since every point on number line corresponds to either rational number or irrational number, the number line is called neither rational number nor irrational number. Neither rational line nor irrational line, but real line. So, every point on number line is a real number. Question 5, the last question. What is the profound consequence of the fact that every point on number line corresponds to a real number? The fact that every point on any given number line, straight line, corresponds to a real number means that any straight line is equivalent to the set of all real numbers. You should know the meaning of equivalence of infinite sets from set theory. Now, Descartes exploited this simple fact of equivalence of straight line and capital R, the set of all real numbers, and concluded that every plane is equivalent to an ordered pair of real numbers, and that every point in space can be uniquely represented by an ordered triad of real numbers. This observation led Descartes to perform the most everlasting and most productive and most blissful marriage in the history of the world. The bond of marriage is this: every algebraic equation or inequation in not more than 3 variables is equivalent to a curve or a surface or some spatial region, finite or infinite, closed or open, so on. I need not exaggerate here the influence of Cartesian geometry, named in the honor of Descartes, in modern mathematics. Before I close, 2 remarks. Firstly, given 2 line segments, to decide whether one is a rational or irrational multiple of other, we perform a procedure which I prefer to call Solomon's algorithm. I just want to mention it without going into the details. Secondly, a number ray is sufficient for showing that all lengths are not rational and some of them are irrational. But we have taken number line to accommodate even the newly born negative numbers. Thank you.